Once again, hello and welcome everyone. I am really glad to see everyone here today. Let me start off with a question for all of you. How many of you had the chance to drink some morning coffee today? Raise your hand, nice and high. Okay, about 50%. Well, guess what? I don't believe you. So I'm going to have to test your energy levels to see how well you're communicating here with me. So what I would like everyone to do is to say test dive, nice and loud and clear. Okay, ready? And... Oh, okay, great. Okay, let's try that one more time. A little bit louder. Ready? And... Fantastic. Okay, now let's complicate things just a little bit. Now, let's say test dive and then clap once, okay? Oh, hold on. Ready? And... Oh, fantastic. Okay, since all of you could follow instructions so well, let's play a little game. Behind me, I have a slide with the letters AI. I have randomly placed this slide throughout my presentation, and it is going to be your job, the audience, to say AI and then clap once whenever this slide appears, okay? So let's do a practice round. Let's say I'm talking, and then all of a sudden... Okay, that was good. Well, let's try that again. So I'm talking, and then all of a sudden... Fantastic. Okay, once again, let's get this party started. My name is Kornaś. I am a software engineer at Nokia, specializing in AI projects. And today, I'm going to talk to you about how easy it is to get started with machine learning. And let me start off with another question. How many of you are new to machine learning or kind of starting off or don't really know too much about it? Raise your hand. Okay, great. I have fantastic news for you. This presentation is for you. We're going to start off by talking about the history, where AI came from, the potential of AI, what it can do, and then get into some specific fundamentals of machine learning. But for those of you who did not raise your hand, do not worry. I have a second part. We're going to go into some real-life examples of how we use machine learning on a day-to-day basis at Nokia. So hopefully, we'll be able to get some inspiration shown for you. So starting off, the theoretical part. Starting off with the question, what is AI? What is this artificial intelligence that everyone is talking about? For many of you, the first thing that comes to mind is, I'll be back. The Terminator, rise of the machines, destruction of humanity, Skynet. For others, the Matrix, being able to upload things to your brain, knowing instantly how to do karate, and all those kinds of things. And of course, for others, Transformers. And I don't know why when I thought about Transformers, I automatically thought about Power Rangers. Because it's almost the same thing, I don't know why. So anyways, AI, something distant, something far from our grasp, science fiction. But in reality, AI is already among us. It's everywhere where we go. It's in our phones, it's on the internet, it's in our cars. People are trying to utilize it, use the potential wherever they can. Basically, AI is the ability of having a computer to do tasks that normally that would require human intelligence to do. And just to be clear, my presentation is supposedly about machine learning. But why am I talking about AI? Well, just for everyone to understand, artificial intelligence encompasses various subcategories. And one of those subcategories is machine learning. So I'm kind of going to be using it interchangeably. For now, I'm going to be talking like a general overview, but later I'll get into the specific subcategory of machine learning. So just for you to know. So now let's start off with the question, where did AI come from? Well, the Terminator didn't say, I'll be back, and then 2 hours later came back with machine learning and AI. As a matter of fact, it started somewhere in around the 1950s, where a group of researchers thought of this crazy idea that, hey, we should recreate the human mind within a machine. Now that sounds crazy, I should say, because they must have been best friends with Albert Einstein, because Albert Einstein once said, if an idea does not sound crazy, it will never survive. So it's something to keep in mind. So these group of researchers got to work. They started working on this AI, how they could implement it in computers, and they kind of started dividing into two main groups, the rule-based group and the neural network group. The rule-based group, they wanted to hard code everything into the machine. All the decisions, everything hard coded. If you see a red light, stop. If you see a green light, go, and so on. And at the beginning, that sounded pretty interesting. I probably would have done the same thing. But later, when things got a little bit harder, the machine kind of just didn't know what to do later. They would have to go interview experts to find out how would they do it, and then go back to the lab and rewrite everything how the machine would later do it. But the neural network group said, no, no, no. We actually want to recreate the human mind within the machine. All the neural network pathways, exactly the exact same way in the machine. So that when we feed it data, it will be able to find out on its own, find out the various patterns and learn on its own. And so at the beginning, everyone thought, that's an awesome idea. Neural network group, you got something going there. But as the years went on, the rule-based group pushed back saying, no, come on. You can never implement such things like that. Forget about it. And so they did. And so most of the researchers went on to work on the rule-based group while the AI network, the AI group kind of left for forgotten. And that's when, during the 1970s, around the beginning time, that's when the first AI winter kind of started. And then later on, as the years went on, the neural network group had a very interesting points of glory. But unfortunately, they went back into the AI winter the second time during the 1990s, almost completely forgotten. But then all of a sudden, let's try that again. And all of a sudden, fantastic. AI finally, finally in the beginning of the 2000s, AI finally came back into the game thanks to two main ingredients: data and computing power. Because during the beginning of the 2000s, everyone started having computers at home. And with that, the internet came along. And then all this data started being aggregated on the internet. And so finally, the neural network group had something to work with. But the results that they were getting just quite weren't there yet. But until later, around the 2012 period, deep learning came along. And it was all thanks to a man named Geoffrey Hinton. See, Geoffrey Hinton and his team entered into a competition in 2012. It was a computer vision competition. And basically, their job was to classify as many possible categories of images as possible. And it turned out they completely destroyed everyone. And it was that point, it was that period of time where AI finally entered its golden era. Everyone started swarming and trying to figure out, CEOs, researchers, scientists, everyone, how can we possibly use this technology because it's so fantastic? And so we had various technologies come along, identity fraud, and all these kind of things, self-driving cars and so on. One major technology that also came out, as maybe many of you have heard, is deepfakes. Deepfakes is basically the ability to generate real images that look completely fake. I mean, there are fake images that look exactly real. And so we're going to play a little game right now. Behind me are two images. One of them is real. The other one is generated by AI. The question is, which image is the real one? So I'll give you a second to think about that. If you think that the left one, your left, the left one, is the real one, raise your hand. Okay. If you think it's the right one, raise your hand. And the answer is? The answer is the left one. Round two. Which one is real and which one is fake? The question is, which one is real? If you think it's the left one, raise your hand. If you think it's the right one, raise your hand. And the answer is the right one. Let's try one more time. Two images. Which one is real? If it's the left one, raise your hand. If it's the right one, raise your hand. And the answer is. So, for those of you who got all three wrong, you're doomed. AI is going to take over you. But if you got all three right, then we're going to probably you're some kind of AI intelligence, and we're going to need some extra security. So please, we're going to need you to get through some extra security checks later on. So please cooperate. Thank you. Another major technology is being able to manipulate videos and audio. As you can see, this is just an example of how we could manipulate various audio, but you could already see this technology being abused on the internet. Recently on YouTube, there have been fake videos of celebrities saying hurtful things and all kinds of nonsense on the internet. And of course, it was completely fake generated. And that's just celebrities. But imagine seeing on your television, or if someone's seeing on your television, world leaders saying that someone's gonna do a strike, someone's entering a war, we're going into war. What kind of chaos that could cause? The type of manipulation that you could use this for. But here comes the plot twist. What if I told you the machine learning has nothing to do with learning? That this AI, that feeding it data and teaching it, has nothing to do with learning. Now I know what most of you are thinking. You're crazy. You must have got this off of Wikipedia. But let me explain. Let's take this image for example. My beautiful image that I drew in paint. I know many of my friends tell me this is the Mona Lisa of 2019. As you could probably guess, it's some kind of wagon. It has two wheels. The two circles probably represent two wheels. The box, it has some kind of container. It's probably three-dimensional, means you could put something in it. If you push it from behind, it will move forward and so on. But if you give this image to one of the state-of-the-art AI models, it will tell you probably that's 90% chance that this is a tennis racket. And so the model would have to be taught on thousands and thousands of various images in order to know that this image is actually a wagon. But for you, you don't need thousands and thousands of images. You could probably automatically tell that that's a wagon. And so that's not learning. And if you slightly distort the image, and I mean, even if the model did learn on hundreds of thousands of images, and you slightly turned the image at 45 degrees and showed the model that it was taught on the previous images, it probably won't know what it is. But probably you could still tell that it's a wagon, even if it's at a 45-degree angle. So, even though AI is very powerful, it can be dumb at the same time as well. One more time. Thank you. So now the question is, what is machine learning exactly? Machine learning. It is basically taking information input, giving it to a model. The model creates a mathematical computation, a formula, that gives a desired output. You have training data. You train that model based on that training data. And once it learns all based on that data, it is able to make future predictions on new data that you provide it with. Jeez. And for example, how does this data look like? For example, let's see how, let's say we want to predict the housing median price within a district. One row, I'm going to use my mouse, which you cannot see, of course. Okay. Take, for example, this first row. This represents one district. And this district has various features, and each column represents one feature. So total rooms, bedrooms, population, and so on. And based on all these features that we have provided here, it should give us a median value of this much. And same thing for the next district. Based on these types of values, it should give us this kind of value, and so on and so on. So basically dividing the data into an X set and a Y set, we learn based on the X information that we provide, and so that it can predict the Y values. So now the question is, how do we get started? We have a general idea of how machine learning basically works. So how do I start training this model? First, we need to choose a programming language. Number one programming language at the moment, of course, is Python. However, you're not limited to Python. You could use Java, C++, and so on. There's tons of various languages that you could use. But based on various results, there's a website called Kaggle that you could train your various machine learning models. This is where companies give various tasks. For example, 2-3 years ago, the FBI posted a task that, based on these images that they provided, create a model that will tell you what is the probability that a person within an image is a terrorist. And of course, the reward for creating the best model was $1.5 million. So, hooray. So, based on everyone who worked and uses Kaggle, most of them actually use Python. And I also use Python as well, so I highly recommend using Python, but you're not limited to it as well. So after choosing Python, there are very basic libraries that you can use. The most popular one is scikit-learn. Scikit-learn basically has a lot of predefined models that you could use, and also using pandas, NumPy, and all those other libraries help you to prepare the data that you will use to train your model. I'll get into the specifics later of how I use that, but a little bit later. And so now machine learning has another subcategory, a few subcategories. 3, supervised, unsupervised learning, and reinforcement learning. What is supervised learning? Supervised learning is when you have data that is already labeled. And so, for example, using this example, spam. You have a set of data that you have classified as spam and a set of mails that you have classified not spam. And you put that into your algorithm, into your model. And it trains and learns, okay, this is spam, this is not spam, and so on. And so when it learns based on those examples, and then takes on new mail, and then it's able to classify based on historical data. Unsupervised learning is when you have a problem, usually met in the real world. You don't have classified data. You don't know which is spam, which is not spam, which is passed, which is failed, and so on. And so you kind of have to start improvising a little bit and to see what the model can possibly classify on its own. So for example, here we have a bunch of dots in our data box, but we can't really, well, logically you could see how it could be divided. And so based on putting it into a machine learning algorithm, it could classify on its own what kind of categories which dots should belong to. And third and not least, the most popular probably library is reinforcement learning. Reinforcement learning is basically learning on the basis of trial and error. Here we have a task, we want to learn how to walk. And so we have an environment, we have an agent. Our agent is our walking stick man, and he wants to learn how to walk. And so he gets plus 5 points for every step he takes correctly, and minus 50 points whenever he falls over. And so based on the pluses and minuses, wherever he gets the highest positive score, that's where he's going to start doing more, and so on and so on. So basically after iteration after iteration, after making many mistakes, he finally, after 201 generations, he finally learns how to quite well walk. Thank you. And so we come to the end of the first part. Now we're going to start the second part, but I need a sip of water first. Fantastic. Okay, now we're going to get into the practical example of how we use machine learning on a day-to-day basis at Nokia. Last year, Nokia came out with this initiative that, hey, we have this machine learning technology, we need to start moving forward in this direction. So my team came together and did a little brainstorming. And so we thought about these various ideas, what we could use machine learning for at Nokia. And so we came up with this idea that we would use machine learning for analyzing the statistics that are generated at the base stations to tell whether or not any problems are occurring. And this would be later integrated in our performance management tests. But let's take a step back and tell you what are these PM stats? What are these statistics? Well, these statistics are basically generated at 5-minute intervals at the base station. And they basically tell us everything that happened within that 5-minute interval, from how many phones were connected, how much data was transferred, how many resources have been used, and so on and so on. So now the question is, why would we use machine learning for such information? Well, the problem is there are over 2,000 different types of statistics or parameters to analyze. And so for us testers, it's quite difficult to analyze every single one in detail. But luckily, we can use machine learning to do that for us. Because when we're working on a specific feature, we're only limited to certain various features, statistics pertaining to that feature. And due to the time constraints in order to pass that feature, we can't analyze every single one and maybe probably miss something. So thanks to machine learning could do that very quickly and effortlessly. So how did we get started? Luckily, we had a set of data from previous tests that has been already classified as passed and failed in our database. So fantastic. We have labeled data, so we could call it supervised learning for classification. So we had to first create a framework that would get all this data, download it, parse it, throw away all the unnecessary data, and nicely put it in a data frame that we would use for our model. Then after we had our data prepared, then we had to choose which model to use. And generally, when you're first starting off, you don't really know which model is best going to work. So the general rule of thumb, try as many models as possible if you can. I know due to time constraints you can't, and usually that's not the case, but if you can, try as many as possible because you never know which one will work the best. And no machine learning expert will ever tell you which model will work the best, because one model will work better on this type of data, a different model will work on a different type of data. So best to try all of them. And so of course we started off simple. We took one type of test case. So for example, how many phones can be connected and to stay connected for a long period of time. And we used that type of test to first test our models. And then once that worked, we started adding more and more different test cases. And so basically, this is how our data set looks like. On the right-hand side, we have our test case. This is the entire test case that lasts, for example, 1 hour. And like I said, PM stats are collected every 5 minutes. So if a test case lasts 1 hour, we have 12 samples of 5-minute intervals. And of course, each column represents one specific feature or one specific statistic. And of course, at the very end, we have our labeled data. So 0 would represent if that test was failed, and 1 would represent if that test was passed. And so for the code, this is pretty much everything that you need to get started. First, you start off with all the libraries that you need. The very bottom line, sklearn svm, import svc, that's where you import the specific model that you want to use. Then, like I mentioned before, when we have our data, we have to divide it into the x, into the y. So x is what we're going to be training the model, and y is what we want it to predict. And of course, that we have to split it into a training set and then into a testing set. We first teach our model based on our training set, and then use the testing set to check the accuracy of the model. And of course, these 3 lines are probably the most important 3 lines. The first one, you define your model with the various hyperparameters that you want to use. Then you use the .fit model to train your model. So you provided the x training data and then the y that it should be predicting on. And then, based on the data that it has not seen yet, you use the .predict method and you record all the new predictions into the prediction variable. And then, of course, at the very end, we want to compare whether or not the model is working correctly. So we compare the predictions to the actual results to see how well it is working. And of course, fantastic results. I'm not going to get too much into the details here, but if you want to know more about it, we could talk about it later. But most important here is the cross-validation score. Basically, our accuracy score at the very beginning was a 98%. So almost perfect. So that's pretty much it of how you could get started with machine learning and become an expert within a month, or at least that's what we thought. Exactly. So we thought we were experts within a month, but actually we kind of faced some problems along the line. One of them was we did not properly normalize or pre-process our data. Instead of pre-processing it before it is splitted, it has to be pre-processed after it was splitted. And the most the cardinal sin that we committed was data leakage, which is basically, instead of, maybe I could go back a second. So basically what would happen, the samples within the middle of the test case usually were somewhat the same. And so what would happen is, for example, this sample would be in the testing set, and the next sample after that would be in the training set. And so what would happen, the model, it would already see a sample that it has seen before, and therefore, since I already saw this is almost exactly identical, it must be this result. And that's not really learning. It's kind of like when a student learns all the answers before going to an exam, and then when he sees the questions on the exam, oh, I already saw this question, it must be B, and so on. So that's not really exactly learning. And so other problems that we also faced along the line. We had unbalanced classes, meaning we had too many test cases that were passed and a few that were only failed. And so because of that, the model tended to be a little bit biased. And because of that, we didn't have enough data to fix that problem. Because normally to fix that problem, you need to add more data, but we couldn't generate more data because that's all we basically had. Another problem, PM stats change too often from feature to feature, meaning, yes, we used historical data from previous years, but if we went too far, it was useless, because what for example, if a statistic, how it worked 3 years ago, changed over the course of time when new features were added. So that's why we couldn't use them anymore, because previous tests thought it will be passed, but now it was failed, and so just nonsense. Improper classification of test cases. Unfortunately, the tests that we do are on physical setups, and sometimes they have hardware problems. And we're aware of these problems, but we still pass the test because it's not the fault of the feature, it's the fault of the hardware. And because of that, they weren't quite correctly classified, and so on. And of course, most importantly, data analysis is extremely, extremely time consuming. You need a lot of computing power in order to analyze hundreds and hundreds of logs of data. So if you don't have the right equipment, it could take quite a long time. And so in reality, we were only getting around 73%. If you look at the bottom here, only around 73%. So we had to get to work. And so the very first thing that we had to do, we had to clean our data. This is the most important thing that anyone can ever do. You need to clean your data, because the type of data you have is only going to be your model is only going to be as good as the data that you provide it with. So even if you have the state-of-the-art machine learning model, it's still not going to be good enough if your data is just junk. So first things first, clean your data. Analyzing correlations between test cases to see if there were any test cases that were similar but were differently classified, that might have kind of faulted in the decision making of the model. Tested multiple models at the same time. We continue to see which model had maybe actually outperformed, worked best, and so on. Feature reduction. Maybe there were some statistics that weren't very important, and we could reduce the number of statistics that were being analyzed. Ensemble learning, using multiple models together at the same time and creating like a voting system. And of course, the most important and also very time-consuming, hyperparameter tuning. Fine-tuning the various parameters that come within the model to see if it works correctly. And of course, after quite some time, we finally got a working, good enough model called XGBoost. XGBoost is a very popular machine learning model used on Kaggle website. Most competitions are usually won using this model, which I don't blame them, because it's a really good model. And we achieved around 90% accuracy. So we were extremely pleased with these results, and it works quite well. And so after finally creating our model, we integrated into our integration tests, and we had, whenever a test is run, it goes through the test, and then at the very end, it collects all the data logs. Those data logs are then sent to our machine learning model. The model analyzes the results, and then it gives a Excel report. And here we have our results. The test case is passed, and for each specific interval, it checks whether or not if anything went wrong there too as well. And of course, we were also able to add this excellent feature called SHAP. SHAP is a very interesting library. It basically helps you to explain why a model had decided to choose left or right, true or false. And so based on using this model, we were able to tell which statistics had the greatest impact in failing or passing a test. So for example here, the SHAP, it has its own numbering value, scoring value. It gave that this specific statistic had the greatest impact in failing a specific test. So thanks to SHAP feature, we were able to find root causes of the problems within our tests. And of course, it kind of works. Basically what to look at here, ML validation status is basically what our automated system gets the answers, the results from our model. And this column is basically the manual checking of the tester. So a tester usually always checks manually whether the results are correct or not. The middle column is an old-fashioned way of how we checked our results, usually using a script and so on. So it works. And so, coming to my conclusion, hopefully I was able to show you that machine learning isn't as hard as it may seem. It's not as scary as it may seem. And as machine learning and AI continues to evolve, it's not only my responsibility, but each and every one of yours to go out and to try out and see where we can apply machine learning on a day-to-day basis, whether it's IT, medicine, business, wherever. Because if we do not go out and see where we could apply this, we will never know. So, one last time. Thank you very much. You are an amazing audience. Thank you.
One, two, 3. Can you hear me? Okay. So now it's a time for your questions to Daniel. So let's see what we've got here.
Okay. So the first question about the real and fake images. What distinguishes the fake ones from the real ones? What can we look for to detect AI? It's a very tricky question, really. Sometimes intuition. I have run this test past a few of my friends, and many of them said basically based on intuition, they kind of felt that something was off by some kind of image. I mean, it's hard. It's hard to tell. I mean, it even fooled me as well. So it's really hard to tell. However, there are researchers working on finding out whether an image is fake or not. Decrypting whether a video or image is a deep fake or not. So there are tools being built to fight this kind of stuff because it is dangerous. It is very dangerous. So, yeah, it's hard to tell as a person, as a human being. But luckily, there are tools that being built to fight this kind of stuff. So yeah.
Okay. So the next question, please.
What is the main obstacle in machine learning implementation? The main obstacle. Analyzing the data, I'll probably say. Analyzing the data. Because it takes really a lot of time to get good data. And a lot of it, especially as well. Because nowadays, no one's really aggregating this data. And this is a problem that we're facing as well. And we're starting to do this in future tests as well. So we're going to start aggregating these logs so that we can have something to work on with. The more data you have, the better the model will work. So basically, the biggest obstacle is data, having a lot of data.
Okay, thank you very much. So now is the time for the last question, the third question. Today for Daniel.
Currently, AI and ML are global trends. What, in your opinion, is the greatest risk to companies and humanity? The greatest risk to companies? Well, in regards to companies, I don't think there's much of a risk, really. It's going to take a while before machine learning or AI in general takes over the world. So you don't have to worry about the Terminator coming after you and stuff like that. But machine learning and AI definitely are going to be good tools to assist you during your working days. So is it a threat? No, not really, at least for now. But when it comes to humanity, as I mentioned before, using deep fakes and fake videos and images to manipulate these kind of things, and especially people all around the world, that could be very dangerous. It's already dangerous and something that we should be taking a look at and being aware of as well. So yeah.
Okay, thank you very much. Ladies and gentlemen, big applause for Daniel and his great speech.